Test 1. Verify that the robotic arm is securely mounted to the test platform by gently shaking it in its deployed and undeployed state. First, the undeployed state. The arm has no loose connections, therefore it's secured in its undeployed state. Now we'll test the deployed state. Testing. All features seem to remain secured, therefore the arm passes test 1. Test 2. Articulate the shoulder vertical joint and time how long it takes to go from 0 degrees to 100 degrees. Pass if this is accomplished in 1 minute or less. Here we can see with a string and protractor that the arm is starting at 0 degrees. Here we can now see with the string and protractor that the arm has passed 100 degrees. Therefore, the arm passes test 2.
Test 3. Articulate the shoulder horizontal joint and time how long it takes to go from 0 degrees to 270 degrees. Pass if this is accomplished in 1 minute or less. Verify angle and time with the protractor, string, and stopwatch. We'll start ensuring that it is starting at 0 degrees. Okay. Use the stopwatch. Oops, stop. Definitely took less than 1 minute. So now we'll verify that we have moved greater than 270 degrees in less than a minute. And as you can see, we've moved greater than 270 degrees. So pass test 3. Test 4. Articulate the elbow joint and time how long it takes to go from 0 degrees to 160 degrees. Pass if this is accomplished in less than 1 minute. Verify the angle and time with a protractor, string, and a stopwatch. So right now we have the system set up at 0 degrees. And then we'll actuate it to 160. So that took 15.5 seconds. You can easily see that we're past 160 degrees. Pass test 4. Test 5. The arm must pick up an astronaut package from the ground and load it onto a basket on top of the electrical rover housing. Release package, pick up the package, put package on the ground in front of the rover. Release it. Pass if the sequence of events can be accomplished. The basket we'll be using is simulated because the rover team has not provided the finished basket this time. And now we'll verify that the astronaut package is indeed 6 kilograms or 13.2 pounds using this scale. And this scale does pounds and ounces, so the equivalent 13.2 pounds is 13.32 ounces. And here we're a little over that, so we're just going to be testing a little harder than we otherwise would be. Should be fine. Now, let the arm go to work. So the package has been released onto the rover as the arm is not holding it anymore. So now I'll pick it up and put it back on the ground. And there we have it. The sequence has been completed. Pass test 5.
Test number 6. Using the control panel with 2-inch radius targets, the arm must be able to touch its equipment servicing end effector to each of these targets as well as touch the ground. Pass if this can be accomplished. And our control panel is set up as per regulation standards. Might be hard to see, but from the base, the control panel is set 45 centimeters away. The targets are 15 and 75 centimeters tall, respectively. All points of interest have been touched. Pass test 6. Test number 7. Using control panel rotated plus or minus 60 degrees from facing the rover, demonstrate that the arm can flip switches from its correct position and mount in front of control panel. Pass if this is accomplished. So at first we will do 0 degrees from facing the rover. And we are still 45 centimeters away from the panel. And the point of interest is between 15 and 75 centimeters. Test 8. Using control panel plus or minus 60 degrees from facing the rover, demonstrate the arm can push buttons from its correct position and mount in front of the control panel with the equipment service end effector. Pass if this is accomplished.
Okay, this is the flipping switches and pushing buttons at 60 degrees.
John will have to be my eyes.
Up and down. Let's do it because I didn't have. Move that. Alright, ready? Jump. Jump down. Just straddle that thing. Open your jaws a little bit. Yeah, I don't know how much. Pull that. That's push button right there. I'll push it over too. Yep. Push. Push us to switch on. Yeah. Flip it. Come here. Slip. Yeah, slip that inside. You're too close. Yep. Not close enough. Just touch it.
The arm push buttons and flip switches at 60 degrees.
Alright, in continuation of test 9, we've got the rover set up at the other 60 degree extreme for the switches, plugs, and buttons test. So here you can see, test 7, 8, and 9, my bad. So here you can see that we've got our protractor set up at 60 degrees relative to the floor tile lines, and that the rover is aligned with the tiles, and that the panel is aligned 60 degrees to that. So with that, I'm going to set this down, and we'll watch this thing.
Test 9. Using control panel Demonstrate that the arm can plug in power plugs with the equipment servicing end effector. The power plugs must start from a dangling position. Pass if this is accomplished.
This is the test where the panel is 60 degrees away from normal to the front of the rover. The setup is a protractor set where 90 degrees is directly normal to the rover, and therefore 150 degrees is 60 degrees from normal to the rover. And here we're using a square and tape. We can verify that the panel is 60 degrees from normal to the front of the rover. And that is a plug plugged in at 60 degrees.
Okay, now we're set up doing the plug. Yep.
Belt.
Plug in, unplug. Verified.
Is that the proper way to unplug the plug?
Test 26 complete. Test 10. Demonstrate that the arm is able to acquire a soil sample weighing between 25 and 250 grams using the soil sample return end effector as mounted to the arm currently. Remove the sample from the arm or container and weigh it. Pass if it is between 25 and 250 grams. Now we'll collect the sample into this plastic bag to put it onto the weight scale. Make sure the device is zeroed. And it comes in at 65 grams. So that is above 25 grams and less than 250, so we passed test 10. Test 12. Demonstrate that the arm is able to orient the sensor plate parallel to the ground and within 6 inches of the ground. Pass if this is accomplished. A ruler may be used to verify distance, and a level may be used to verify parallelism. So first, verify that it is parallel. Check that it is parallel. And I'll verify distance. Using the 6-inch long ruler. So the end of the ruler is in the dirt and obviously touching the ground. So the sensor plate is within 6 inches of the ground. Pass test 12.
Test 14. Using a string and protractor, verify that the end of the end effector is within the arm camera's 60-degree field of view. We can see it's within 10 degrees, which means we passed test 14. We also need to test this from a side view. As we can see, the angle is still 10 degrees. Therefore, we passed test 14. Test 15. Using a long straight object, touch one end to the end effector and the other to a position within the Rover main camera's field of view, as represented by this cardboard behind the Rover arm where the camera will be. This test requires that we only be able to touch the straight object in one position. We can easily touch the object in many positions, which means the arm passes test 15.
Test 16. Position the wrist roll to one of its extremes, then count the number of rotations it can do before mechanically or electrically stopping. As we see here, it is at one of its extremes. It has stopped. So now I'll start counting when this point passes my finger. Two and a half-ish. So that's more than 2 full rotations past test 16.
Test 18. Attach and remove each end effector. The attachment process should involve only a single connection operation to make both electrical and mechanical connections, once per end effector installation. Pass if this is true. not assistance end effector is completely installed. Pass test 18.
Test 19. Move the arm to stow position. Look to see if stow position trigger switch is engaged. Pass if switch is engaged. Switch is engaged. Test 19 pass. Test 20. Verify that the arm is securely stowed by gently shaking it in its stowed configuration and look for unconstrained arm structure that would allow for any part of the arm to exit the stow volume. Arm secure. This can be checked with the stow size gauge. Pass if no structure exits stow volume. All the arm is in the stow volume. Test pass.
Test 21. Time the complete removal of the arm from the Rover chassis. This includes the electrical connection and the mechanical connection. The requirement was for this test to be finished and complete in less than 5 minutes. Pass test 21.
Test 22. Move the arm into stow position and place the stow size gauge around the arm. Here we have our stow size gauge. Pass if stow size gauge fits around the arm with no interference. Stow size gauge easily fits around arm. Pass test 22.
Test 23. Place the arm on a scale and weigh it. Pass if the arm weighs less than 20 pounds. Pass test 23.